Hi guys, क्या हाल चाल है भाई? Hello everybody. How are you guys doing? कैसे हो आप लोग भी? Hi guys. Hi Shri Ram. Hello Nazla. Hello Shreyansh. Hello Shivam. So how are you guys doing? भाई सब कोई I hope everybody is healthy. Everybody is doing good. पढ़ाई वढ़ाई सब कुछ ठीक ठाक कर रहे हो. So today, our discussion around the S block will come to an end with the last leg of discussion, which is around alkaline earth metals. We have been discussing, we have completed hydrogen peroxide, water. We've completed alkali metals and properties and compounds of alkali metals, and we will be discussing alkaline earth metals. Okay, now there is a small bit of a change when it comes to my classes, since Paul sir is back, so I'll be taking classes on alternate days. So my classes will be held on Monday, Wednesday and Friday. Okay, Monday, Wednesday and Friday. Monday for 11th standard, since you're in 11th standard, so my classes will be held at 10:30 a.m. Okay, 10:30 a.m. So Monday, Wednesday and Friday my classes will be held at 10:30 a.m. Please do join me on these very days. ठीक है? मेरी classes सिर्फ 3 दिन ही होंगे. ठीक है? चलो. So let's start the discussion around the alkaline earth metals, and we have already discussed alkaline earth metals properties and a little bit of chemical properties. Let's try to explore some more chemical properties. A very small, very interesting topic, and this will not take a lot of time to finish. Okay, now that you know a lot of stuff. So let's start with the first question, that hydrides as well as halides of alkaline earth metal tend to polymerize for which of these alkaline earth metal? Okay, hydrides as well as halides of alkaline earth metal tend to polymerize for which alkaline earth metal? बताइए, for which alkaline earth metal the hydrides and the halides will undergo polymerization? The right answer, please give me the right answer in the chat box. We had discussed this in the last session towards the end. What would be the right answer? What would be the right answer? Anybody? The right answer should turn out to be beryllium. The right answer should turn out to be beryllium, the smallest one. It has the maximum tendency to undergo polymerization. So BE. Answer will not be strontium. Strontium is not alkaline earth metal. Sorry, strontium is alkaline earth metal. I'm very sorry. Confused with rubidium. But strontium is very large. Cannot undergo polymerization. So BeCl2, it will form a dimer. BeH2, it will also form a polymeric entity. So the right answer is C. The smallest atom will have the maximum tendency to undergo polymerization. So let's start with the chemical properties. Now, if you recall chemical properties, this is known, we have discussed a bit of chemical properties. Today we'll start with hydroxides. Now how are hydroxides prepared? Hydroxides are prepared when you take these metal oxides and add them to water. Okay, you take these metal oxides and add them to water. So if you know, calcium hydroxide is known as lime water and barium hydroxide is known as baryta water. BARYTA. It is known as baryta water. Both of them are basic in nature. So it is already written over here that beryllium hydroxide is amphoteric. Only beryllium hydroxide is amphoteric. Rest all of them are basic. BOH2, it will react with both as HCl and base. It will react with both HCl and base to give two different products, and so it is known as an amphoteric compound. The rest all of them are basic. All of them will give out OH minus ion. Also, they are utilized to detonate carbon dioxide, because when we pass carbon dioxide through the solution, then a white precipitate is obtained. Insoluble white precipitate is obtained. Now, you might know this experiment to identify carbon dioxide. What we do is we take CO2 and pass it through slate lime. Calcium hydroxide is known as slate lime. So it will give CaCO3. However, if you pass excess of carbon dioxide in aqueous medium, then you will get calcium bicarbonate. You'll end up getting calcium bicarbonate. So this is obtained as a precipitate, but this is soluble. So that is the reason you will have to be very, very careful about how much amount of carbon dioxide you should be passing through the solution, because if you pass more carbon dioxide through the solution, then what will happen is whatever calcium carbonate could have gotten formed, it will also undergo dissolution in the formation of due to the formation of calcium bicarbonate. Okay, chalo, let's move on to the next one. What are the chemical properties? Salts of oxyacids. Oxyacids. I told you that what are oxyacids? H2SO4. Okay. H2CO3. HNO3. These are oxyacids. So if I take carbonates, please do remember that carbonates and sulfates are the ones which are mostly asked in examination. Carbonates and sulfates. So in carbonates are like salts of these metals with CO3 and CO3 2 minus unit, and sulfate is salts with SO4 2 minus. So carbonates, they are insoluble in water. Calcium carbonate is insoluble in water. Okay, because they are precipitated, and they can be precipitated by addition of sodium and ammonium ammonium carbonate from top to bottom. So solubility of carbonate decreases. As we go from top to bottom, the solubility of carbonate decreases. Now, why does the solubility of carbonate decreases? Because when you dissolve something, then the hydration energy should be more than the lattice energy. Okay, if you want to dissolve something for dissolution, then the hydration energy has to be more than the lattice energy. But as you go down, then the size of the atom increases. You start from beryllium and you go and become barium. Barium is a very large ion. Barium's tendency to undergo hydration is very less. Though the lattice energy is also lesser because the ions are larger, but the hydration energy is even lesser than the lattice energy, and so the solubility of the carbonate decreases. Okay, the same goes for calcium to barium sulfate. So when you talk about the solubility of the carbonate and sulfate decreases from top to bottom. Okay, sulfates are all stable to heat, and beryllium and magnesium sulfate are only soluble in water. Beryllium carbonate is unstable and it is kept in CO2 atmosphere. So please do remember that for anything to dissolve, hydration energy has to be more than lattice energy. As you go down, hydration energy decreases, lattice energy decreases, but hydration energy decreases to a greater extent as compared to decrease in lattice energy. So hydration, the amount of energy given out upon hydrating the ions is very less, and that is not compensating for how much amount of energy which was given out when lattice was getting formed. Okay, so the right answer to the question that what is solubility trend, solubility will decrease down the group. Okay. So next question is, which of the following is least thermally stable? What is lattice energy? Lattice energy is the amount of energy which is given out when you bring an ion from infinity and place it at certain lattice positions. Lattice is like an arrangement. It's like a brick in a wall. Okay, so the whole room's structure is a lattice, and you can consider the barium and the carbonate unit as the wall, as the bricks in a wall. So the amount of effort that you would require to bring these bricks and to put them in a wall, and the amount of energy that will be released for that. Okay, so in this process will turn out to be the lattice energy. So which element have lowest hydration energy in the periodic table? See, we are talking about groups. Okay, lowest hydration energy, if you talk about the largest atom will have the lowest hydration energy. The right answer in that case will turn out to be, in you for your question, the right Avik Arya, the right answer will turn out to be cesium. Okay, cesium. The least thermally stable. How do you identify thermal stability? So thermal stability is directly proportional to ionic character. Directly proportional to ionic character. And how do we identify ionic character? Ionic character it is decided by Fachans rules. Okay, it is decided by Fachans rule. If I take a small cation, then the polarizing power will be higher and it will have more covalent character. So beryllium CO3 will be most covalent. Size of cation is less, covalent character is more. Size of cation is more, covalent character is less. And strontium carbonate is least covalent. So least covalent will become more ionic. The right answer should be C. Okay, the right answer should be C, SrCO3. Okay, SrCO3. Which of the following alkaline earth metals carbonates is thermally most stable? Thermally most stable. In this case, which is the right answer? So now you have magnesium, calcium, strontium, barium. अब आपको बताना है कि इसमें thermally stable कौन सा होगा. Okay, so which is the most thermally stable entity? So thermal stability is dependent on the ionic character. The one which has the highest ionic character will be thermally most stable. So Mg Ca, Mg2 plus Ca2 plus Sr2 plus Ba2 plus. The largest ion is Ba2 plus. So largest ion is Ba2 plus, least covalent character, most ionic character. Answer should be D. Answer should be D. Guys, why are you marking? How are you getting calcium? Is thermally most stable will be BaCO3. Okay. So Ba2 plus is largest in size, which means least polarizing power, which means least covalent character. Okay. Chalo, let's move on to certain compounds. So we start with the first compound, which is important, that is quicklime. Quicklime is CaO. Quicklime is CaO. And how do we obtain CaO? Calcium oxide is obtained By heating calcium carbonate in a rotary it's a furnace, okay, and so you heat it at a higher temperature, at elevated temperature, carbon dioxide will be completely removed and you will have CaO. Okay, what is the behavior of quicklime? Quicklime is quicklime is a white crystalline solid, and on exposure to atmosphere, when it is exposed to ambient conditions, then it will absorb moisture and carbon dioxide. So it is being utilized to trap carbon dioxide as well as to trap H2O. So calcium oxide reacts with H2O to form slate lime, and CaCO3 is formed. Okay, it is the cheapest form of alkali used in the cement industry. It is used in the manufacture of soda ash from caustic soda. Na2CO3 from Na2CO3 is washing soda as well, and from NaOH utilized in purification of sugar and manufacture of dye and stuff. If you go for slate lime, Manikandan, I'm not gonna say that my classes will be enough for inorganic. After the classes, you also need to read books, you need to solve questions. It has to be 3 things which has to be done properly: watch lectures, read books, solve questions. Okay, all these 3 things have to be done if you want to ace an examination or you want to master a particular subject. Okay, how do we prepare slate lime? We take calcium oxide and just put it in water. It is white amorphous powder. It's known as lime water or slate lime. Okay, suspension is known as milk of lime. If I pass excess carbon dioxide, so CaOH whole twice, if reacts with CO2, what will happen? Okay, it will form CaCO3 plus H2O, and then if you pass more carbon dioxide, I did tell you that it will form a bicarbonate which will be soluble. And one of the most important behavior of calcium hydroxide or slate lime or lime water is that it reacts with Cl2. Dipole moment, man, that is already covered in chemical bonding. Okay, you can watch the older videos of Paul sir in which he has covered dipole moment, okay, in chemical bonding. So calcium hydroxide will react with chlorine. CaOH whole twice reacts with chlorine, and it results in the formation of bleaching powder. It looks like CaOCl, Cl, calcium oxychloride or bleaching powder. Okay, calcium oxychloride and bleaching powder or bleaching powder. So what are the uses of slate lime? It is used to prepare building material, it is used as whitewash due to its disinfecting nature, and it is used to prepare bleaching powder. It is used in glass industry, fanning industry in preparation of bleaching powder and purification of sugar. What is plaster of Paris? You know what is plaster of Paris? POP. Plaster of Paris is most commonly known as POP. POP walls. We use plaster of Paris for creating the casts if there is a fracture in one of the bones. So what we do is we take gypsum, calcium sulfate dihydrate, and we heat it at 393 Kelvin. So we obtain calcium sulfite hemihydrate. Gypsum at 120 degrees Celsius will form plaster of Paris. If you heat it to 200 degrees Celsius, you will get anhydrous calcium sulfate. Okay, so plaster of Paris, if you add water to it, it will just turn into a hard solid. Rather than dissolving, it turns into a hard solid. That is the reason you can prepare a cast. You can prepare different shapes using plaster of Paris. No, plaster of Paris and cement are different. Plaster of Paris and cement are different. Okay, false ceiling in houses is made up of plaster of Paris, or in a classroom false ceiling is made up of plaster of Paris. Cement is not used in making the false ceiling or false partitions. So let's take this question. So let's take this question. Which of the alkaline earth metals are with respect to alkali metals? What do you think will be the right answer? What do you think will be the right answer? They're more reactive, they're more reducing, more oxidizing, they're less basic than alkali metals. More reactive, no. Alkali metals are more reactive. More reducing, they have a high reducing power, no. More oxidizing, metals do not behave as oxidizing agents, metals behave as reducing agents. So this is also not an improper. Less basic than alkali metals, yes. Alkali metals try to form the strongest bases in the periodic table, and metals, any other metal will form a weaker base. So right answer should be, okay, right answer should be D. So with this we finish S block. Okay, we finish S block with this. In the next class on Friday we would be doing a quiz session. We'll be taking questions, some previous year's questions or some more relevant questions, objective type. We'll try to solve as many questions as possible in a given duration, and we will try to understand what are the various things we should be keeping in mind so as to make as less mistakes as possible when it comes to the S block elements. Okay? So chalo, with this I take leave. I hope you have enjoyed S block. Please do watch all the videos, read books and solve questions. Okay, you cannot excel unless and until you do all these three things. My lectures are not only sufficient, anybody's lectures are not only sufficient. You have to couple it with a lot of hard work. Okay, chalo. So with this I take leave, and let's meet on Friday and revise alkali metals and alkaline earth metals. We will have a quiz. Okay. The best book of inorganic Joel Paul would be J.D. Lee, Comprehensive Inorganic Chemistry, or you can also go for O.P. Tandon, Cengage, NCERT. All of these are good books. Okay. Chalo. Bye bye guys. Have a lovely day.